So this is still water rolling.
सर आपकी स्क्रीन नजर नहीं आ रही है.
स्क्रीन नजर नहीं आ रही है, एक सेकंड. हाउ अबाउट द अदर्स?
आ रही है
विजिबल है सर.
आ रही है
हाँ
सर.
आ रही है. एक मिनट जरा, इफ यू कैन जस्ट exit and then come back again.
Yes sir, will do.
You have to silence your mic. Yeah. Okay. Is it visible now?
Yes sir, thank you.
Okay. So we're now doing rolling of a vessel, also called as still water rolling, also called as harbor water rolling, also called as undamped rolling. All these are synonyms of the same thing, also called as undamped rolling, and also called as natural rolling. So for vessels which are length less than 70 meters, or also called as coasters or small vessels, the GM of the vessel can be estimated by what is called as the rolling period test, which is given by a straight formula. The GM is equal to F into B upon TR whole square, where F is the rolling coefficient, and its value varies from 0.78 to 0.73 to 0.88. Where 0.73 is for loaded vessel and 0.88 is for vessel on ballast. B is the breadth of the vessel. TR is the time period of roll. So as per
topic.
just for one batch, I'm just revising it for one particular batch.
So TR is rolling period, right?
TR is the time period of roll. TR is the time period of roll in seconds.
Okay, sir.
So this is also called as the rolling period test, which was done in your phase 1 cargo. And this is applicable for vessels which are small in length, that is up to 70 meters. So less than equal to 70 meters. They are also called as coasters.
So the F is rolling constant.
F is a rolling coefficient.
Coefficient.
Yeah, F is a rolling coefficient. The for vessels which are larger vessels or R kind of vessels which are more than 70 meters, for time period of roll, there is a formula. So TR is equal to 2 pi K over G into GM fluid. It's a simple harmonic equation. TR, time period of roll, is equal to 2 pi K over G into GM fluid under the root. So therefore, over here, K is the radius of gyration or constant of gyration. K is the radius of gyration, also known as the constant of gyration. So
सर डिनोमिनेटर में ब्रैकेट में क्या है सर जीएम के आगे सर
fluid, GM fluid.
सर इसमें कोई शिप कोस्टर है कि नहीं वो हम लेंथ से डिसाइड करेंगे कि वर्ड मेंशन होगा कोस्टर.
अगर कोस्टर है तो इसका मतलब है ये है.
तो भैया ये पास्ट पेपर्स में एक क्वेश्चन है जिसमें दे हैव मेंशन अ कोस्टर ऑफ लेंथ 80 मीटर्स.
हाँ, अब ये जो सो दिस बिकम्स ये एक्चुअली टेक्निकली गलत क्वेश्चन है, बट सिंस एक ये ऐसा क्वेश्चन आया था जबकि कोस्टर ऑफ लेंथ 80 मीटर्स, तो कौन सा होना चाहिए, ये होना चाहिए या ये होना चाहिए, तो दैट बिकेम अ बिट ऑफ अ इशू एंड कंट्रोवर्सी. सो कोस्टर के लिए फिर ये फॉर्मूला है एक्चुअली मेंशन्ड, सो यू आर सपोज टू यूज दिस.
अगर उन्होंने स्पेसिफिकली कोस्टर मेंशन किया तो फिर हम लेंथ वो लोग कर देंगे.
तो हाँ, that's right, because basically the question is trying to indicate that the vessel is going to be around the coast and is not going to go on to the high seas. So how do such vessels behave basically, and how can the GM of these vessels, such vessels, be estimated by measuring the time period of the roll? That means the vessel first rolls on to from midship, she goes to starboard, and then she goes to port, and then she comes again to midship. So once that happens, or to upright, the time period that it will take from starboard to port to midship is the TR, is the time period of roll in seconds. So
सर ये टॉपिक में स्टिल वाटर के साइड में क्या लिखा है प्लीज बताएंगे. HBR
harbor water, harbor water,
हार्बर वाटर.
harbor water. Harbor water, sheltered water, vessel in break, inside breakwater, मतलब ये सब एक ही चीज को इंडिकेट कर रहे हैं. And so therefore, from this particular this thing, the inferences that can be drawn are that time period of roll is inversely proportional to the square root of the GM. So therefore, more the GM, lesser will be the time period of roll, and vice versa. So therefore, you will write one paragraph about stiff vessel and one paragraph about tender vessels. How stiff vessels have a higher GM, kg is lower, so therefore the time period of roll becomes small, So violent rolling happens, uncomfortable for people on board. When the GM is small, the TR becomes large, and so therefore tender vessel and long rolling. Radius of gyration is basically the distance the weight is away from the center line of the vessel, about the axis about which the vessel will roll. So therefore, how much distance are you away? That means, so basically, that is, so what is gyration or radius of gyration? So if you have a disk which is a irregular disk, which has got an irregular mass, and if you rotate it around a particular axis, which is known as the rotational axis, then the center of mass is found to lie at a certain distance away from the rotational axis. That is known as the center of mass. The distance the center of mass is away from the rotational axis is known as k, the radius of gyration. What is the application of this on our ships? Well, our ship, I've got weights which are away. So therefore, if I've got weights, if my vessel is rolling very heavily, then if I move my weights which are away from the rotational axis nearer to the center line, then I would be reducing the rolling. So reduction in rolling can happen in three ways. First, by shifting weights from port and starboard side towards the center line. Second, by ballasting centerline tanks. And third, by deballasting wing tanks. So by these three methods, I would be in all these methods. What I'm doing right now is basically I'm leading to a reduction of K. And if my K reduces, my TR is directly proportional to K. So that means I will lead to a reduction of time period of roll. TR will reduce. This is known as still water rolling, also the harbor water rolling, also the undamped rolling.
सर ये एक बार रिपीट कर देंगे सर रेडियस ऑफ जायरेशन
Basically, the distance that is away. So, in the case of a ship, basically, the ship rolls about an axis which is passing through the COG of the vessel. The ship is rolling around about that axis. So, if I have weights which are there on my port and starboard side, then my rolling will be more. If I shift those weights towards the center line, I'm going to be reducing the weights off centered, and therefore I'm reducing the K, and therefore I'm reducing the TR. So reduction in rolling can be achieved by three methods. One is shifting weights from port and starboard side towards the center line. Another is if I ballast the center line tanks. And a third is if I deballast the wing tanks. In each of these cases, I will be reducing the radius of gyration. Okay. Now, the vessel is going to be at sea. So at sea, the vessel is going to be under the effect of waves. So heavy sea rolling, at sea rolling, also called as damped rolling. Damped rolling, also called as rolling under waves. Rolling under waves, and the effect of waves and effect of sea, basically. All of these come under the terminology or whatever of what is called as damped rolling. So when you are in damped rolling, vessel will be encountering line of waves. These are the line of waves. So the waves come and hit the vessel from a particular direction. So the angle which the line of waves makes with the fore and aft line, center line of the vessel, is theta. And theta is known as the angle of encounter. Theta is known as the angle of encounter. So generally what happens is the first wave which strikes the vessel then gets rebounded backward and फिर वापस जाती है. And then it meets the second line of wave which is coming. And then it retards that particular second line. So the first wave which comes and hits the vessel first is known as the primary wave. The primary waves rebound from the vessel and go back. And then they meet the next second wave which is going to come in and retards it. So the second wave which comes and hits the vessel is called as a secondary wave. And the sequence then carries on. For us, what is important to note is that basically the angle theta, the angle of encounter, will matter to me what kind of a force the line of waves is going to make and going to have an effect on my vessel to roll. So if this be the TR, the time period of roll, the natural roll period of the vessel. And there is a certain time period of the waves also which is hitting my vessel. If the time period of wave TW, they become in resonance with each other, the resultant is an unduly large roll which is called as synchronous rolling.
सर एक बार फिर से ये एक्सप्लेन कर दीजिए क्योंकि इंटरनेट चला गया था ये वेव वाला जो डायग्राम है.
So I have TR which is the टाइम पीरियड ऑफ रोल, द नेचुरल रोल पीरियड ऑफ द वेसल, वो इनहेरेंट है उस जहाज का। और टी डब्ल्यू इज द टाइम पीरियड ऑफ द वेव जो एनकाउंटर मार रहा है जहाज के साथ और जहाज को हिट कर रहा है, वो एक्सटर्नली मार रहा है। इफ द टू बिकम इन रेजोनेंस विद ईच अदर, दे गेट सिंक्रोनाइज्ड, they result in what is called as TS, or synchronous rolling, or the time period of synchronized rolling period of the vessel. This TS further, when she goes into a resonance with the pitching period, translates into what is known as
Parametric.
parametric rolling on specific types of ships only, not on every vessel. But this fellow can occur on your vessel, my vessel, any vessel. It can occur on tankers, it can occur on bulk carriers, it can, because this is dependent on the time period of the wave which is going to hit me. So, how to get out of synchronous rolling? You alter your theta. You alter your theta and you break the resonance. The idea is you cannot reduce TR, that you can't touch. But, and you can't do anything to the wave also. Wave is going to come in at its own period. But what you can control is the resonance of the two, which is what you do when you alter your course or you reduce your speed. Or sometimes you do both, a combination of the two also at sea. To weather the storm, you do both. You alter your course and you reduce your speed. So this is all about your damped rolling, waves rolling, rolling in waves, rolling at sea, synchronized rolling. These are all the various names given to it. Synchronized rolling. So basically, it's the effect of the waves on the vessel and how it hits. Haji, any questions?
सर इस पे क्वेश्चन कैसा आएगा? दे लास्ट की in a way of short notes.
Write short notes on what do you understand by harbor water rolling, rolling in the seas, rolling in heavy seas, things like that. Write short notes. So ये सारा जो राम कहानी है सारी एक्सप्लेन कर देना, TR की एक्सप्लेन कर देना, TW की एक्सप्लेन कर देना, फिर TS एक्सप्लेन कर देना. ठीक है? Is that okay?
Yes, sir. Sir, I had one question.
बोलो.
So parametric rolling normally, what I have heard is normally it depends on how the swell will, from the direction from where the swell will hit the vessel. Normally it is more it affects when the swell is coming from the stern or from the quarter or from the bow.
So basically, so it's connected. अगर आपको पैरामेट्रिक रोलिंग हटानी है तो आपको ये टीएस को हटाना है.
Yes.
अगर मैं टीएस को हटा सकता हूं तो मैं पैरामेट्रिक रोलिंग को हटा रहा हूं.
Yes.
टीएस को मैं कैसे हटाऊंगा? मैं थीटा को ऑल्टर करूं, एनकाउंटर को ऑल्टर करूं. मुझे इसकी रेजोनेंस तोड़नी है ना बेसिकली, क्योंकि इसकी रेजोनेंस के साथ में जुड़ी है पिचिंग की रेजोनेंस।
Yes.
तो मैं इसकी रेजोनेंस को पहले तोड़ता हूं ना, बाय रिमूविंग थीटा। सो विच इज व्हाट आई डू। सो वो जो मेरे को मास्टर्स गाइडेंस दी हुई है वो यही काम करती है। That's what it does.
Okay. Sir.
Let me try and show you a movie. I've got a short clipping of a parametric rolling. Let me just show it to you so that it will give you an idea of what I'm talking about.
Okay, sir.
Is the screen visible?
I
No,
can't
sir.
see anything.
Is it visible to everybody?
Yes, sir. Now it's visible.
Yes, sir. Now it is visible.
Okay. Let me know when you can hear the sound.
So the screen is stuck up.
Okay. Can you see the screen?
Yes, sir.
Okay. The Ro-Ro passenger ferry, the model. Are you able to see the model?
Yes, sir. Video is not yet playing, sir.
Video is not yet playing. Correct. I've stopped it. I'll just. Notice how the wave height is in how the parametric is. The freak. Notice how it's building up. Can you see now?
Yes, sir.
Yes, sir. And basically, it starts with pitching, then it's
Correct.
build up to rolling.
Absolutely right. Basically वो हो रहा है कि पिचिंग से चालू हुआ था वो रेजोनेंस जो जब मिला उसको वो रेजोनेंस का सारा सारा खेल रेजोनेंस का है
So one आपस.
All right. See you tomorrow then.
Yes, sir. Thank you. Thanks a lot.
Yeah. Okay. See you. Bye.
Bye.